In this video, we will be learning how to solve literal equations. And these are equations without numbers. This is just solving for a variable, and we want to manipulate it so that we get that variable on one side and everything else on the other side. So for the first problem, we'll be looking at this one. A very simple one. We are solving for r, and we have w equals q times r. But before we get there, I want to show this same structure, but using numbers and only one variable. So as you can see here, we have 6 equals 3 times r, or 3r. And this is the same exact structure as the problem we were doing. Pretend this is a w and this is a q. Now, this is a very easy equation to solve. Using our inverse operations, we know that since this is a 3 times r, this is multiplication, we need to get rid of this 3 by dividing in order to get r by itself. So if we divide off the 3 here, we must divide it on the other side as well. And then now, once we do 3 divided by 3, we would get 1r, or just r. And on the left side, 6 divided by 3 is simply 2. So if this were a normal equation, not a literal one, this would be perfectly solved. R equals 2, everything would be good. However, we don't have 6 and we don't have 3. Instead, we have a w and we have a q. Yet everything else is going to stay exactly the same. Now, we can see that we have w equals q times r. That relationship is still multiplication. So we still need to divide, but instead of dividing by 3, we're going to divide off the q because we want r all by itself. And when we do that, we need to do it to the other side as well. And now we divide off the q's because q divided by q is going to give us 1, as we saw with 3 divided by 3, or anything divided by itself will always give us 1. So it'll give us the r all by itself. And now we have w divided by q. And well, those aren't numbers. We don't know what w and what q are. So we can just leave that as is. W divided by q. It's just describing that relationship. To make this a little neater, we'll just replace this sign for this long line, which represents a fraction, which is still division. It's still the same relationship. And now we can see that we have r all by itself and everything else on the other side. So we have solved for r. And in this case, r is equal to w divided by q. The next problem we will look at is this one. We're going to solve for x, and our equation is y equals mx plus b. Now, before we get there, I want to go through an example one more time where I replace the variables with numbers. So in this case, the 14 is the y, the 5 is the m, and the 4 is the b. And we get 14 equals 5x plus 4. So again, we already know how to solve this. And the first thing we want to do to get x all by itself is we need to get rid of this plus 4. So we subtract 4 from both sides. And I'm going to write this a little funky. But this is the same as this, 14 minus 4. And this will come in handy later once we have variables and not numbers. But since they're both like terms, I can just go ahead and do that arithmetic and get 10. So we get 10 on the left. And now we will get 10 equals 5x. And that's because these 4's canceled out. And then 14 minus 4, you can combine those to make 10. So now it's pretty simple. We just divide off the 5. So we divide 5 from both sides. And again, I'm going to write this a little weird, but this is the same operation. And if you remember from the last example, this will come in handy as well once we change all this to variables. But 10 divided by 5, we can just write it as a fraction like this, 10 divided by 5. But again, these are like terms, so we can just do the arithmetic there and get 2. 10 divided by 5 is 2. And then finally, on the right, the 5's turn into 1, so 1x is just an x. We get x equals 2. Now, this was a great example with numbers, but now we're going to go back to our initial example with a literal equation. So I will replace the 14 with y. I will replace the 5 with an m. And I'll replace the 4 with a b. Again, we have the same relationships, except now we have different letters instead of numbers. But as you can see, the b is still being added, the m and x are still being multiplied together, and the y is still over here all by itself. So now, to get rid of this b, again, how we got rid of that 4, we now want to get rid of this b by subtracting b. And of course, we need to do this to both sides. So we'll subtract b from both sides. But now we don't know what y is and we don't know what b is. So we can't do that arithmetic and combine it to make a 10 here. Instead, we'll write it out like how we wrote it initially by doing y minus b. And if you remember, when we had a 14 and a 4, we did 14 minus 4. But in this case, we can't combine these, so we just have to leave it as is, y minus b. This 5 is now an m from just carrying it down. And of course, this is m times x, so the inverse operation to get rid of this m is division, like how we did with the 5. So now, instead of dividing by 5, we're dividing by m. And we have to do the same thing to this side. We can't divide by 5 there. We need to divide by m, keep it the same. And once we do that, we have y minus b divided by m. Well, that's not 2. But we can't combine these. Y minus b stays the same. Y minus b. And again, we don't know what m is. We can't combine it. There are no like terms. So if you remember, I did 10 divided by 5 in the previous example. I just took whatever was here, divided it by this 5 that was here, and I put it into a fraction to do 10 over 5. Now we'll do the same here, except it has to stay this way because we can't combine. We can't divide this and get a number. So we'll just leave it as this. Y minus b divided by m. We have x all by itself, which is what we wanted. And so this is the final answer. X equals y minus b divided by m. For our final example, we'll be looking at this problem right here. We want to solve for y, and we have ax plus by equals c. Now I have set it up here. We have a times x, ax, plus b times y, or by, equals c. And I'm actually not going to replace anything with numbers, because the goal here is to practice what we've learned using our inverse operations to get y by itself. And realistically, when you encounter these problems on your own, you really don't want to be plugging in numbers and then replacing them. So this will be a good test. So again, we want this y all by itself. And the easiest thing to get rid of is on the other side of this addition sign, this ax. It's kind of loosely attached to it. So we can just get rid of this and move it over to the other side. And we don't even have to break it up. We can just take this whole component and move it over. So if we subtract ax from both sides, which is perfectly acceptable, especially because we don't know what values a and x are, so we can't combine them, or we can't divide this off because it's being added. So we can just treat this as a whole term, subtract it from both sides, and it would move it over here. And in doing so, we have by left over. And on the other side, we can't combine anything. These are all different terms. We have c and we have ax. So that'll just simply be c minus ax. Now, we almost have y by itself, but it is being multiplied with the b. So, since it's multiplication here, we need to do the inverse of that, which is division, to divide off this b. So we can just go ahead and do that. We can divide by b now. And everything on this side is being divided by b. And we'll see that in action. So once we divide this b off, it's b divided by b is 1. So 1y is just y. And on the other side, we still have this c minus ax up top. But all that is being divided by b. What you could have also done is break this fraction up into 2 and do c divided by b minus a divided by b. Those are both perfectly acceptable. But usually you'll try to keep things simple, place it all under one denominator, and here we have our final answer. Y equals c minus a times x divided by b. So to recap, when solving literal equations, we just solve them exactly like any other equation, except we have letters instead of numbers, but you still use those same inverse operations to get that variable that you're trying to solve for all by itself.